Hello. In this video, I will be covering linked lists, nodes, and pointers in C++, continuing our journey through fundamental data structures. So what is a linked list? Well, a linked list is a linear data structure where elements, called nodes, are connected via pointers. Unlike arrays, linked lists do not require contiguous memory. A node is an element containing data and a pointer to the next node. A pointer stores the address of another variable, or node. And a singly linked list, or SLL, each node points to the next node only. So let's take a look at our first example here, which defines our basic structure for the node. As you can see, we are creating a struct called node, which has two things. First, an integer that has data, and another node that which is a pointer called next. So in our main function, first we're declaring a linked list that is empty, i.e. we're creating a new node called head and making that a null pointer. And then next we're creating a single node. So we're creating a node called node 1, which is a new node. We are assigning the data for that to be 10, and we're saying the next to be null pointer, i.e. this node is the only one in the list. So the head is going to point to node 1 because the head has to point to the first node, and node 1 is the only node that is there. And then we're printing that out, the data, that is, using the arrow notation. And then finally, we're freeing the memory to prevent leaks and returning 0 for a successful output. So let us compile this and run it. So as we can see here, the first node data is 10. Again, struct node defines a node with data and a pointer to next. New node dynamically allocates memory for a node. Head points to the first node, and delete frees memory to prevent leaks. So now let's look at a next example, which is a little more complicated. It's a singly linked list. We're creating this with multiple nodes. So first, we're creating 3 nodes and assigning their data. So for head, second, and third. Then we're assigning data. So the head is going to be 10, the second is going to be 20, and then the third is going to be 30. Then we are connecting the nodes. So head, the next for head is the second one, the next for second is third, and since the third one is last, the next one is null pointer. Next, we are traversing the list. As you can see, we are creating a temporary pointer called current. We're assigning that to be the head. And then while the current is not null pointer, we are printing out the data and then iterating current to be the next one. And then finally, we are freeing the memory, so head, second, and third, because it's always good practice to free memory. This program demonstrates the dynamic nature of linked list. It's not a fixed size like an array. So let us compile this code and run it. As we can see, we iterate through each data of the particular node, so 10, 20, then 30. Finally, let's look at our final example here, which is inserting at the beginning. So again, we have our same struct node, just like in the last one. And then in our main function, we're declaring a head to be a new node. We're declaring that data to be 20, and then the next to be null pointer. So right now, as of as the end of line 12, the linked list only has one node. But starting on line 15, we are inserting a new node at the beginning. So we're going to call it new node. We're going to make the data 10. We're going to make the next to be the head. So this one, the original sole node. And then we're making the head equal to the new node, i.e. we are inserting the new node at the beginning. And then we're doing a similar thing as last time. We're traversing the linked list, setting current to be head, which is our temporary variable. And then while current is not null, we are printing the data out and then iterating to the next node. So we're freeing up memory. So new node and then the original head. And then we're returning 0 for a successful operation. So let us compile and run the code. As we can see here, it prints out 1020. And as you can see here, there's some issues because I did not properly free the memory. So some key takeaways to this program. One, a linked list is a dynamic, non-contiguous data structure. Nodes contain data and a pointer to the next node. Pointers allow dynamic memory linking. And linked list can be traversed, inserted, and deleted dynamically. Singly linked lists are the foundation for stacks, queues, and more advanced structures. As a challenge activity, see what you can do to prevent the program from crashing. How do we need to free the memory up better? If you found this tutorial helpful, do not forget to like, subscribe, turn on notifications, and leave a comment. Please reach out if you have any questions. Otherwise, thank you for watching and have a great day.